On July 15, 2025, our sun unleashed a spectacle that stunned scientists and stargazers alike. A massive solar filament, an enormous dark ribbon of plasma, suddenly erupted after days of tense stillness. This wasn't just another solar flare, it was a colossal explosion, hurling energy and particles into space. Observatories worldwide captured the eruption, providing rare insight into the sun's raw power. The event was a vivid reminder. We live next to a dynamic, sometimes volatile star. For scientists, it was a live experiment in solar physics, impossible to replicate on Earth. The eruption connected researchers and the public, sparking conversations about space weather and our technological vulnerability. It showed us that the universe is alive, ever-changing, and that understanding our star is crucial for our survival. We are truly fortunate to witness such cosmic drama from our tiny spaceship Earth. So, what is a solar filament? Picture a gigantic dark ribbon of plasma suspended above the sun's surface. These filaments are cooler and denser than the surrounding corona, making them appear as dark threads against the sun's bright face. They're held aloft by powerful magnetic fields like a magnetic hammock cradling solar material. Over days or weeks, these structures store immense energy, twisting and stretching as the sun's magnetic forces shift. When the magnetic hammock snaps, the filament erupts, often triggering a coronal mass ejection, or CME. If a CME is aimed at Earth, it can disrupt satellites, power grids, and communications. That's why tracking filaments is vital for space weather forecasting, our early warning for cosmic storms. These tense ribbons are key to understanding and protecting our technology-dependent world. The July 15th eruption began days earlier, as scientists tracked a massive filament over 400,000 kilometers long, rotating into view. Magnetic energy built up beneath it, twisting tighter like a stretched rubber band. The tension grew until finally the filament began to rise, slowly at first. Suddenly the magnetic forces snapped, unleashing a burst of energy. The filament whipped into space, while a brilliant solar flare ignited at its base. Spacecraft like the Solar Dynamics Observatory captured the eruption in stunning detail. The resulting CME billowed outward, confirming our theories about solar eruptions. This event was a textbook example of solar physics: slow buildup, sudden release, and a massive expulsion of matter. It was a rare chance to watch the sun's power unfold in real time. Each eruption teaches us more about the forces shaping our solar system. At the heart of the July 15th eruption was magnetic reconnection, a fundamental, explosive process. Imagine the sun's magnetic field lines as elastic bands. When oppositely directed lines are forced together, they snap and reconnect, releasing stored energy in a violent burst. This energy accelerates particles and heats plasma to millions of degrees, powering solar flares and CMEs. In this eruption, reconnection beneath the filament cut its magnetic tethers, launching it into space. It's like a sudden release in a tug-of-war. All the tension vanishes in an instant, flinging plasma outward. Magnetic reconnection isn't unique to the sun, it happens across the universe, but our star is the best place to study it up close. Observing these eruptions helps scientists refine their models and predict space weather. Understanding this process is essential for protecting satellites and power grids on Earth. The sun's eruptions are a cosmic laboratory revealing the secrets of energy release in the universe. The July 15th eruption launched a massive coronal mass ejection, a CME, into space. Unlike a solar flare's flash of light, a CME is a physical cloud of plasma and magnetic fields traveling millions of kilometers toward the planets. This particular CME was huge but missed Earth. Had it struck, it could have triggered geomagnetic storms, disrupting power grids and satellites. Past events like the 1989 Quebec blackout show how vulnerable our technology is to solar storms. CMEs can also disrupt radio, GPS, and even threaten astronauts with increased radiation. But there's a bright side. CMEs create spectacular auroras, lighting up the skies in vivid colors. These storms remind us of our deep connection to the sun and the need to prepare for its outbursts. Each CME is both a threat and a cosmic light show. Our challenge is to enjoy the beauty while safeguarding our modern world. The July 15th eruption was part of solar cycle 25, the sun's latest period of rising activity. Every 11 years, the sun's magnetic field flips, driving cycles of quiet and stormy behavior. As we approach solar maximum, eruptions like this become more frequent and intense. Solar cycle 25 is already more active than expected, making space weather forecasting critical. Our reliance on satellites, power grids, and global communications means we're more vulnerable than ever to solar storms. Past near misses like the 2012 CME remind us how close we've come to disaster. The July eruption is a wake-up call. Our technology and daily lives are tied to the sun's moods. Vigilance and improved forecasting are essential as we navigate this active phase. Understanding our star isn't just science, it's survival. We witnessed the July 15th eruption in detail thanks to a fleet of spacecraft and observatories, our guardians in orbit. NASA's Solar Dynamics Observatory captures high-definition images of the sun every few seconds, revealing eruptions as they unfold. The Solar and Heliospheric Observatory, or SOHO, tracks CMEs and gives us crucial early warnings. New missions like Parker Solar Probe and Solar Orbiter are flying closer than ever, sampling the sun's corona and magnetic fields. Together, these missions provide a comprehensive view, from the sun's surface to its farthest reach. Data from all these observatories feeds into models that predict solar storms and their impact on Earth. This global effort protects our technology and inspires us with the sun's beauty and power. Our eyes on the sun are essential, keeping us safe, informed, and connected to the cosmos.